Hi, everybody. My name is Dr. Anna Smith, and this is a very short activity that I hope will help you see the idea of relational understanding in action and how useful it can be as a teacher and how your results are often a bit better from using it. So let's have a quick look at relational versus instrumental tuition. So instrumental teaching involves a set of instructions where, whereas relational understanding requires teaching a concept. So this can be more challenging at times for the teacher as well. So you need a deeper understanding of what you're teaching. That means that you can be flexible about how you explain something. You can draw on ideas quite impulsively, without too much planning. And if you contrast that with a learned list that is required, that's instrumental teaching. So you can see that a learned list doesn't really require much flexibility. You will literally go through each step and there won't be much flexibility there or creativity, but equally, there won't be a lot of meaning gained from this list. Relational understanding achieves longer lasting and flexible application of knowledge. And a real example might help you see how useful this can be, and it might help to illustrate the contrast. So I've got a real example here. When I was younger, I was teaching statistics in King's College London. I started off teaching very heavy concepts by the book, so really quite instrumental in the way I approach things. So started really from basic aspects of statistics to the higher level stuff like multiple regression. But we don't need to know too much about statistics um, for this activity. So all I would like you to do is just perhaps get your idea around what a standard deviation is. If you haven't seen this before, a standard deviation is really the value that describes the distance of a set of scores from the mean. So if you've got a cluster of scores, you want to know, are they all wide-ranging and away from the mean, or are they all clustered around the mean in some tight grouping? So knowing the standard deviation allows you to make all sorts of assumptions about the distribution of scores. It's very useful, but that's probably beyond what we need to know right now. What we want to do is encapsulate the set of distances in just one value. That's our target. A low standard deviation indicates that the data points tend to be close to the mean and the data is clustered and consistent, whereas a higher standard deviation indicates that the data points are spread out over a wide range. So they're further away from the mean, so there's more variability. So here's my instrumental approach. So here you can see it's very formulaic. I've got step one, two, three, four, and five. And there's nothing wrong with that. You could learn it like that. You could have it on a list and just rehearse it a lot and see if it will go into your long-term memory. But I'm going to break it down a bit, but just show you the steps first. So show you the instrumental approach. So you can see here, step one, take each score away from the mean. So 6 is taken away from 4, and you've got -2. 6 is taken away from 5, you've got -1, and so on. So I've got a set of scores. My next job is step two, square each value. So I'm squaring each value. So I've got 2 squared is 4, 1 squared is 1, and so on. Okay. So this is my next step, the product of my next step. Step three, add up all the values. Okay, I'll do that. That's step three. 4 plus 1 plus 0 plus 1 plus 4, that's 10. All right. Step four, divide by n. That's my sample size. I've got 5 scores. So it's 10 now, divided by 5 equals 2. Step 5, square root the final value. So the square root of 2 is 1.41. So that's my instrumental approach to the standard deviation. Not really very relational teaching at all. So how might I teach that in a relational way? Here we go. I've added a relational column here. So this is the column that says, well, why am I doing this? And perhaps that will help me remember it, okay? So if it has meaning, then it will remind me of the step that I need to take. So we've got the steps as before on the left-hand side of the table. So why are we doing step one? Why are we taking each score away from the mean? Well, this is the essence of the standard deviation. We're looking for those all important distances. So This is the sensible place to start. These final values are the distances, right? That we are going to start with to create our one value. That makes sense. Step two, square each value. Okay, why? Why do I have to square each value? Well, you've got to square the values because if you didn't and you added up all of those five values, because some are below the mean and some are above the mean, they will all cancel each other out and you'll be left with zero. And that's not really helpful to us because we do want those distances. We want to capture the distance, and that means that we have to deal with those positive and negative signs. So a good way of doing that is to square numbers. If you square a value of -2, you will lose the minus number. So -2 squared is 4, -1 squared is 1, and so on. And you can see now that we've lost our positive and negatives. So we've got something that we can work with there. Next step. Okay, we need to account for all of those distances, not just one of them. So we're going to have to add them up. Okay. And we're really going to want to find some kind of average there. So we're going to add them all up. We get 10. And then the average part of it is dividing by the sample size, which people probably know. That's how you get a mean. So 10 divided by 5 is 2. So we could stop there, except for we did square them, didn't we? So my final step, which is find the square root of the final value, okay, is to do the reverse of the squaring. So square root is the reverse squaring. So you're bringing that higher number back down again so it has meaning within the context of your scores. So you can now see that 1.41 is quite meaningful when you looked at the original distances at the top there. It kind of summarizes them up into a number that we can make use of. So what I've done here is I've tried to attach some meaning to each of those steps, which will hopefully help you remember how to calculate a standard deviation. So obviously you don't need to remember this because it's not possibly part of your way forward, but it does give you a real life example of how you can do relational teaching, develop relational learning as an alternative to instrumental learning. Thank you very much for your time.